Okay, we're on page 69 in your journal. We're going to be talking about modeling equivalent expressions with word phrases. So it gives you an algebraic expression, okay, which means it has a variable in it, and it's going to give you all of these ways to write it as a word phrase. And so the ones that I'm going to star, so notice x plus 13, all right, is read the right way. Or the normal way you're used to hearing. But x is there first, so 13 is going to be added to x. So add 13 to x. So I'm going to star the ones that the order is switched in the words. The x comes first in the expression here, but it comes second in the word phrase. So we have the sum of x and 13. Okay, your answer, whatever your answer is going to be 13 more than x, and then x increased by 13. Okay, then we have subtraction. The ones that are starred are going to be switched. So for example, x is sitting there and then someone's going to come and take 6 away from it. So 6 is actually subtracted from x. Subtract 6 from x. We have 6, the answer is going to be 6 less than x, or you're going to take away 6 from x because x was there first. You can also say x was decreased by 6. You can still say x minus 6. You can also say the difference. Okay, difference is the answer to a subtraction problem. So the difference of x and 6. And then we have this right here is multiplication. So you have 5 times x. These x's are not multiplication signs, they're variables. Okay, they're a variable is like an unknown number. So you have different ways to write multiplication because they're transitioning you out of writing the x for the multiplication sign. So you have 5 times x, the number, if you're going to squish them together like that, the number has to come first. You could use parentheses to show 5 times x, or you can use the dot to show 5 times x. So 5 times x, you have x multiplied by 5. Okay, that one switches the order. You take x and multiply it by 5. 5 was there first. The product of 5 and x, or you can also write 5 groups of x. So those are ways, the word phrases for multiplication. Division is very simple. Okay, we're going to mark this out and just put and 2. So x divided by 2, they could write it in fraction form or with the division sign. X divided by 2, or the quotient of x and 2. So division is the easiest because they won't change the order on from your expression to your word phrase. So let's look at some examples. We're going to write a word phrase. So we could write any of these subtraction up here. All right, so I'm just going to say 8 subtracted from t. It's just one example. You could put a lot of different ones. This is n divided by 6. I could also say the quotient of n and 6. Multiplication, I could say 4 times w. I could say w multiplied by 4. I could say the product of 4 and w, or I could say 4 groups of w. I could say z plus 8. I could say add 8 to z. I could say the sum of z and 8. I could say 8 more than z. Or I could say z increased by 8. This is, the dot means multiplication, so I could say 9 times m. I could say the product of 9 and m. I could say 9 groups of m. So there's lots of options for your word phrases, but here we're going to write the algebraic expression. All right, it has to be in a specific order. So the sum means to add, of p and 12. So p plus 12. I decreased by 7. The quotient of r with a divisor of 3. So I could write it like this or this. Z decreased by 1. And the product of y and 19. So I could write it like this. I could write it with parentheses. I could put both of them in parentheses. But those are going from word phrases to algebraic expressions. All right, so let's turn to page 71 in your journal. And we're going to be modeling it now with pictures. So an algebraic expression does not have an equal sign. Okay, it does not have an equal sign. And it has one or more variables. Okay, and remember, a variable, okay, a variable is a letter or symbol that represents an unknown number. So it's kind of like a question mark. And then of course your constant is a number that does not change. Okay, so if you had x plus 2, 2 would be your constant. All right, so when you come here, you have, it says the model shows, and it's just 5 circles, so it's 5, and you have 5 circles here, so it's just showing you that 5 equals 5, all right? So we call these algebra tiles. Your tiles can be any shape. They can be rectangles, triangles, it does not matter. All right, so if you have this, now this is an equation because it has an equal sign, but this is how you would draw a model, okay? This would be an example. So for 2, you would draw 2 circles, right, and say that they're positive 1 in each one. And a lot of the time you're not going to have this plus sign here. Sometimes they will, sometimes they won't. But when you have it all in one place, they're going to assume that you're going to combine these. So 2 plus something equals 5. So for that 5, I showed 5 ones. So this would be an example for this equation. All right, so let's look at these. You have, these are actually equations, not expressions. So you have 3 x's, so this could be x plus x equals, and then you have 9 of these. But when you have x plus x, that's repeated addition. So you could also write it like x times 3 equals 9. All right, and so then you have this one. You have 4 circles, so that could be 4 plus, and then again you could say x plus x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's one way to write it. 4 plus x equals 13. And x is all of the same number, okay? I didn't say that the x's were different. X is the same number. It's equal to the same number. Has the same value. So you could also write it 4 plus, since this is repeated addition, you could write it as x times 3, or 3 times x, equals 13. So this model could represent this equation or this equation. All right, so let's look at number 3 on the back. This is on page 72. So this model represents, so they give you an expression, 3x plus 6. So they give you kind of an example. So they showed you 3 x's. You're looking for 3 x's plus 1, 2, 3, 4, 5, 6. So this model, they're asking you which one represents 4x plus 3. So you're looking for 4 x's, so 1, 2, 3. That would be 3x plus 1, 2, 3, 4. Not quite matching up to this one. We want one that's equivalent to it. And then we have 1, 2, 3, 4. That's 4x plus 1, 2, 3. That looks like it could be equivalent. This one is 1, 2, 3x. And again, it doesn't matter the shape of the algebra tiles, just what they're equal to. Plus 1, 2, 3. That doesn't quite match up. And then you have 1, 2, 3, 4 x's plus 1, 2, 3, 4. And that's not equivalent to that as well. So it's going to be